Let's see. Okay. All right. So today we're going to be talking about combining functions. Everybody have a handout? Anybody missing anyone? So when we talk about combining functions, we'll do two types of combinations today. The first one that we'll talk about is called the algebra of functions. The algebra of functions, and then we'll also talk about the composition of functions. So the algebra of functions is just where you're going to be like adding, subtracting, multiplying, dividing. And then composition of functions is where you're plugging functions into other functions. So we'll look at both of these types of combinations today. The first one we'll do is algebra of functions. That's the easier one. So here are the rules for the algebra of functions. So suppose f and g are functions, then f plus g of x is equal to f of x plus g of x. Very simple, very straightforward. If it's f minus g of x, it's just f of x minus g of x. Just make sure you have them in the correct order. So if it's f minus g here, it should go f minus g on the other side. F times g of x is just f of x times g of x. And then the last one, f divided by g of x, is just f of x over g of x. And then they have this extra piece in here that g of x is not allowed to be equal to 0. This is important when you are finding the domain of f divided by g. So that's a little extra piece you'll have to add in there, and remember to consider whenever you're finding the domain. All right, so let's talk about domain. That's the hardest part of this algebra of functions piece, is finding the domain. The top part is really easy. It says the domain of each of these new functions consists of the common elements in the domains of f and g individually. All right, so the domain consists of the common elements in the domains of f and g. So that's the important piece there. I'm going to write you like a little step-by-step guide for how to find the domain. All right, so step 1 is find the domain of f. So you're going to find the domain of f, and then you're going to graph it on a number line. So I'll just draw a little number line here to remind us of that. Step 2 is find the domain of g. And then graph it on a number line. At this point, you would have to consider, if you are finding the domain of f divided by g, don't forget this extra piece. So we'll just add in a little note here. We have the extra piece for f divided by g, where we have to figure out where is g equal to 0. And then the last step is to figure out where those domains overlap or what they have in common. So we'll just say figure out what the domains have in common. That's the phrasing that they used in the textbook. Right, so you find the domain of f, find the domain of g, and then figure out where do they overlap at, or what do they have in common. Okay. Now, we're still going to be using our domain rules that we learned earlier in the semester, the 3 rules that deal with fractions, even index radicals, and then for all of our other functions from the domain, just all real numbers. All right, so let's look at our first example. We'll start off with an easy one. Consider the following functions. F of x equals the absolute value of x, and g of x is x minus 4. All right, it wants us to find a formula for f divided by g of x and then simplify, and then we'll find the domain. Okay, so we're finding the formula for f divided by g of x. So that rule for algebra of functions told us to do f of x over g of x, right? Very simple. So all we're going to do is we're going to look and we're going to say, okay, well, they told us that f of x was absolute value of x. So just replace f of x in the top with the absolute value of x. And then in the denominator, we have g of x. They told us that g of x was equal to x minus 4. So that goes in the bottom. You're done. There's nothing you can simplify here. There's nothing you could, no like terms to combine. So you're done. So this is our formula for f divided by g of x. And a lot of these will be like that. They'll be pretty simple, not a whole bunch of work to do. Like I said, the domain's the harder part. So we're finding the domain for f divided by g. It says to write our answer in interval notation. So step 1 was find the domain of f. And then graph it on the number line. So let's look up here at f of x. So that's f of x. It's not a fraction, it's not a radical, so the domain's all real numbers. So it's all real numbers. All right, so let's graph that on the number line. We're just going to show you the whole thing. All right, step 2, find the domain of g. All right, let's look up here at g. G of x is x minus 4. Again, that's not a fraction, it's not a radical. So the domain's all real numbers. So that's why I was saying this is like an easy one to start off with, because we got these easy domains. Go ahead and graph that on the number line. Now we're almost done. Normally we would just right now find the overlapping pieces, or the common parts, the parts that have in common. But we have to remember that extra piece, because we're doing f divided by g. So we have this little extra piece where we need to find where is g of x equal to 0, or what makes g of x equal to 0. Because that's our denominator now, and we do not want to divide by 0. So we've got to go over here and figure out, okay, what's going to make our new little denominator right here equal to 0? All right, so we're just going to do x minus 4 equals 0. This is a simple denominator. This time we're just going to move that 4 over. We have x equals 4. We want to leave this out. So we need to exclude this. Exclude this from your domain. Because that's going to make us divide by 0, which we don't want to do. All right, so let's get our domain together. This is our step 3. So we're finding the domain. If we look at the overlapping pieces here, they're exactly the same. So nothing to worry about up here. But we do need to leave out 4. So let's draw our number line, mark the number 4. We want to leave that out, so we'll do parentheses. So we'll do parentheses here and here. Everything else is okay. So shade the whole rest of the number line. All the other numbers are fine except for 4. So now we just need to put this in interval notation. So the domain starts over here at negative infinity. Remember, we're always reading these left to right. So we go from negative infinity to 4. Do y'all remember how we represent that little gap? Yeah, the union. Good job. Then we pick back up at 4, and we go all the way to positive infinity. All parentheses here. All right, so just to remind you of what we did. We found the domain of F. It was the whole number line. We found the domain of G. It was the whole number line. So nothing to worry about with these two functions. We did have to worry about, okay, what's going to make our new denominator equal 0? So we found out what's going to make our denominator equal 0. We said we got to leave that out. So we drew our number line, left that one number out because everything else was fine according to step 1 and step 2. We just had to leave out that one number. Then we just converted it to interval notation. So not too bad to start off with. We'll have one later that's a little bit more difficult. All right, let's look at another example with different functions. All right, so still working with some pretty easy functions here. F of x equals x, and g of x is x cubed minus 13. You can see on this example, we're not finding the domain. We won't have to worry about that. The first part says find a formula for f plus g of x and simplify. So we're just going to write our little rule for f plus g of x, which is f of x plus g of x. So we'll fill in those, and then we will combine any like terms, and we'll be done. Okay. And again, these are all rules for functions. So functions have all these nice properties, and they behave really nicely. That's why it's so important that we're able to figure out something's a function. All right, so f of x is going to get replaced with x. That whole thing gets replaced with x plus g of x gets replaced with x cubed minus 13. Now you can be done at this point. This is fine to leave your answer like this. If you prefer to write it in descending order, you can put the x cubed in the front plus x minus 13. But either one of these are fine. This answer here is not wrong. So that's fine to leave that as your answer. On the test, I would probably write them in descending order just because I think it looks a little bit neater. Like if it was a multiple choice question. All right, so up until now, we've been plugging in variables. We've been plugging in the variable x. On this next example, we're going to be plugging in a number. All right, so the rule is, if you plug in a variable, you get out a variable. If you plug in a number, we should get out a number. There should be no variables in our answer. All right, so let's look at the second piece. Find f times g of negative 2. F times g of negative 2. So the rule for f times g, I'll just write it over here. F times g of x is f of x times g of x. We're going to be using that same rule. It's just that x is getting replaced by a number. So we're going to do the same thing. We'll have f of negative 2 times g of negative 2. Now, at this point, I like to go off to the side and figure out what f of negative 2 is and what g of negative 2 is. So I just kind of come over here and do a little bit of scratch work, just to keep it looking neat. So f of negative 2 and g of negative 2. Again, I'm just using my functions up there at the top. All right, so f of negative 2. So I'm going to go to f, and everywhere there's an x, I'm going to plug in negative 2. All right, so plugging in negative 2, that just gives me back negative 2. All right, g of negative 2, that one's a little bit harder. Everywhere there's an x, we're going to plug in negative 2. So it's going to be negative 2 cubed minus 13. Remember, anytime you're raising a negative number to an exponent, you're going to put it in parentheses. So it's going to be negative 21, I think. Negative 8? Yeah, negative 8 minus 13. Yeah. All right, now we've got our numbers, we can just go plug them in. So f of negative 2, we said that was negative 2. All right, so that's negative 2. Just put it in parentheses, make it look neat. All right, negative 2. And then times g of negative 2, we said was negative 21. So what's negative 2 times negative 21? Definitely positive. 42. All right, so like I said before we did this problem, you plug in a variable, you get out a variable. You plug in a number, you get out a number. All right, so if you end up with a variable in your answer and you plug in a number, you know you did something wrong. You know you missed something somewhere. So you should get one number as your answer for those. I think we have one more. Yeah. I always like to do one for f minus g. I'm actually going to add something onto this one. I'm going to just add on let's do minus 2 right here. So cube root of x, and then on the outside, minus 2. So it's not underneath the radical. Okay. So I always like to do one for f minus g because this is the one that's easiest to mess up on. And what people usually will forget to do is you have to remember to distribute the negative here. I would say in college algebra, that's probably the most common mistake on every test, is forgetting to distribute the negative. So anytime you do an f minus g, you want to keep that in your head, okay? I have to distribute the negative. Don't forget. All right, so let's find a formula for f minus g of x. Again, the rule tells us that it's just f of x minus g of x. So now we're going to plug in our functions. F of x is x cubed plus 1. So that whole thing gets replaced with x cubed minus 1 for starting plus 1. All right, and then minus. And here's where we're going to add something in. We're going to put this part in parentheses so that reminds us to distribute the negative. All right, so g of x is the cube root of x, and then I added on that little -2 there, or -2. All right, so cube root of x minus 2. All right, so let's distribute the negative, and then combine like terms. All right, so we have x cubed plus 1 minus the cube root of x plus 2. All right, so like terms here, we just have this guy and this guy. It doesn't matter what order you write this in, I just typically put the constant at the end. So we would have x cubed minus the cube root of x, and then plus 3, because it's 1 plus 2. And that's it. That's our formula. There's no like terms to combine here. You can't combine x cubed and cube root of x. Let's find the domain. It says find the domain for f minus g of x. Write your answer in interval notation. All right, so remember our rules. Step 1, find the domain of f. Step 2, find the domain of g. We don't have to worry about the denominator this time because we're doing f minus g instead of f divided by g. All right, so domain of f. F of x is x cubed plus 1. It's not a fraction, it's not a radical. So the domain's all real numbers. So shade the whole thing. All right, domain of g. Draw my little number line. Now we do have a radical here, but remember our domain rule is for even indexed radicals, like square roots, so like square root of x, the fourth root of x. Well, I don't know how that works. This is an odd index radical. So the domain still are numbers. So there's no domain rule for odd index radicals. It's just considered all other functions. So the domain is still all numbers. I forgot to write it here. There we go. All numbers. All right, now you're just going to find the overlapping part. They're the exact same. So step 3, which is to find what parts they have in common. They have everything in common. So we can just shade the whole number line. And if we're writing interval notation for that, that would be negative infinity to infinity. Okay. All right, I think that was our last example for algebra of functions. We're going to move on to composition of functions. Yeah. This homework is really short. There wasn't a ton of problems that I liked, so the homework's really short. And I think the mastery level is only 50%. So you only have to get, I think there's 4 questions, so you have to get 2 right. This is our definition of the composite function. This little tiny circle here, that little tiny circle, is read as composed with. So that little tiny circle is read as composed with. All right, so it says the composite function, f composed with g, looks like fog, but it's f composed with g, also known as the composition of f and g, is defined as, all right, so here's how I would read this. I'm gonna write it off to the side. F composed with g is equal to f of g of x. All right, so f composed with g is equal to f of g of x. When I write this on my own paper, I like to make like a significant difference between the parentheses. So I would write it more like f, then big parentheses, and then on the inside, g of x. To me, it just makes it easier to read that way. So f of g of x. And then we have the rule for the domain here, which we'll come back and talk about a little bit. It says that x is in the domain of g, so that means find the domain of g like normal. But we have to tweak some stuff to find the domain of f, because g of x is what's supposed to be in the domain of f. So we'll come back and talk more about that. But really all we're doing here is we're just plugging functions into other functions. So you can see we're plugging the function g into f. Now you can use other letters other than f and g. You can even compose a function with itself. So you can have something that looks like f composed with f of x. Or you could have totally different letters. You could have like r composed with s of t. So as long as you see that little circle, that means use this rule, but rename the functions and variables so that they match yours. All right, so let's look at an example. These are pretty easy. All right, so the same rule applies here. If we plug in a variable, we're going to get out a variable. If we plug in a number, we're going to get out a number. So it says find a formula for f composed with g of x for the following functions. F of x equals x cubed minus 3, and g of x equals x squared plus x. All right, so f composed with g of x. Try to make your little circle small so that it doesn't look like an O or a 0. All right, so f composed with g of x. The rule told us that this is equal to f of g of x. You always on these problems, you will always start on the inside. So start on the inside. So start on the inside. And here it's just telling us replace g of x with what they told you it was. So they told us that g of x was equal to x squared plus x. So just replace that whole thing with x squared plus x. All looking a little bit better. We're down to just one function, just f. And now this is telling us, go to your function f, and everywhere there's an x, plug in x squared plus x. So everywhere there's an x, we're going to plug in x squared plus x. I don't know what happened, but maybe it's okay. All right, so we're going to take our function f. Everywhere there's an x, we're plugging in x squared plus x. All right, so here we go. It has x cubed, so that's going to be x squared plus x cubed minus 3. And that's it. It didn't ask us to simplify. So we're done. So just plugging functions into other functions. And the most important thing to remember is, of course, first this rule, but second, to always start on the inside. That's the rule regardless of if you're plugging in a number or if you're plugging in a variable. All right, so let's look at another one. I think we're finding the domain on this one. Yeah. I took this one straight off of the homework. So you may see this exact same example. You may have like slightly different numbers. It says find a formula for f composed with g of x, and then find the domain of f composed with g of x. Okay. So let's get started. Let's write down the rule for composition of functions. F composed with g of x is equal to f of g of x. Start on the inside, go ahead and replace g of x with what they told you it was. They said it was x minus 4 over 3. So this whole thing right here gets replaced with x minus 4 over 3. Excuse me. All right. Like I said before, now we're doing pretty good. We have gotten rid of one of our functions. We only have one function left here. So we're just going to go to our function f, and everywhere there's an x, we're going to plug in x minus 4 over 3. So this x is going to get replaced with x minus 4 over 3. All right, so square root of x gets replaced with x minus 4 over 3, and then plus 2. Again, it didn't say to simplify. Let's check really quick and see if the directions on here said to simplify on the homework. Because if it does, I want to show you how to simplify it. Yes, simplify your answer. Okay. All right, so let's simplify this. All right, so we just need to combine this into one big fraction. So I'm going to actually go off to the side here. I'm just going to look at the inside part. This is just going to save me a little bit of writing. And I'm going to combine that into one big fraction. I got to get a common denominator to do that. So I'm going to write this little 2 as 2 over 1. So now they both have denominators. All right, so I want to get a common denominator because anytime I'm adding or subtracting fractions, I have to have a common denominator. So between 3 and 1, what would be my common denominator there? Good, 3. So I need to multiply that denominator by 3. And anything I do to the bottom, I also got to do to the top. That means I'm not changing anything. Because this 3 over 3 is really like equal to 1. All right, so let's see. We have x minus 4 over 3 plus, that's 2 times 3 is 6 over 3. Now we can just combine the top, bottom stays the same. It's supposed to be equal signs. All right, so combine the top, bottom stays the same. X minus 4 plus 6 all over 3. Now you could probably do this in less steps than what I'm writing now. So that's x plus 2 over 3. All right, so now just go back and plug that in. Put it under the square root. So square root of x plus 2 over 3. So that's our formula. Now, if you had like a perfect square in the bottom, you could take this even further. You could split it up into the square root of the top over the square root of the bottom, but 3 is not a perfect square. It's not going to simplify any further. So we're done. But now we need to find the domain. I'm going to add in an extra page since we've already used a bunch of this page. All right, so we're going to find the domain of f composed with g. So remember what that rule said. It said x is in the domain of g. But g of x is in the domain of f. I'm going to explain what that means when we get there. But the first thing you need to do is just find the domain of g normally. Find the domain using your normal domain rules. So domain of g. So that first line there just basically says, find the domain of g like normal. And what was g? It was x minus 4 over 3? Yeah. All right, so g of x was x minus 4 over 3. Now this is a fraction. But is there anything we could plug in that would make the denominator 0? There's no variable in the denominator. So there's nothing we could plug in that would make that denominator 0.
So it's going to be all.
Yep, so the domain's all real numbers. We could write it as a little number line. I think it helps to visualize the domain that way. All right, so the next part. G of x is in the domain of f. Okay, so let's think about what that means. That means we're plugging g into f. So if we go back to the last page, we plugged x into g, but we plugged the whole thing g of x into f. So here's what we're going to do. We're going to find the domain of g like normal, or sorry, domain of f. Find domain of f like normal. And then replace x with whatever your formula is for g of x and solve. And that'll tell us our domain of f. Because instead of plugging in x, we're plugging in g of x. So that's why we're replacing x with the formula for g of x. Okay, domain F. All right, so f of x was the square root of x plus 2. Oops. All right, so remember our domain rule for square roots. We take the right hand and we set it greater than or equal to 0. So take your right hand, set it greater than or equal to 0. Then we're just going to move that 2 over, just subtract 2 from both sides. So we got x is greater than or equal to -2. But we're not done, because once we've got x by itself, we're going to replace x with g of x and solve. All right, so they told us that g of x was x minus 4 over 3. So you can add in this extra step if you want, replacing it with g of x, and then saying, okay, well, they told me g of x is x minus 4 over 3. Okay. Now we're just solving for x. First thing that's in our way here, we got this fraction. How can we get rid of that denominator? Good. Multiply both sides by the denominator. So we cancel out over there. Then you got x minus 4 greater than or equal to -6. Now we'll just add 4, move that over. You got x is greater than or equal to -2. It ended up being the same. That was just a coincidence. All right, now let's write that interval notation. Let's do our little number line. Mark your number, which is -2. This is all the numbers that are greater than -2. That would be the right-hand side. But should we use a parentheses or a bracket? Good, bracket. So we're shading to the right. We're going to open that bracket up to the right. So we're using the bracket because we have that equal to in our inequality. We're almost done, I promise. This was probably the hardest problem of the whole section. All right, so now we got to just combine the domains. So take into consideration anything we need to leave out of G. Everything was fine in G. So nothing to consider there. So we just have to worry about the domain of F in this example. So our domain of F composed of G of X is, again, nothing to worry about with G. We did have some stuff to worry about with F. So we're just going to copy over that domain. So it started at -2 with a bracket, and we shaded all the way to infinity. That's it. You're done. We have about 5 more minutes. I want to show you this next one really quick. And then I have one from the homework that I'm going to show you really quick. All right, so this is our last one, F composed with G of 2. These are typically easier. Anytime you're plugging in a number, it's a little bit easier. You know you're not going to have to worry about domain on these problems. All right, so find F composed with G of 2 for the following functions. F of x is x cubed plus 1, and g of x is x plus 5. All right, so we have f composed with g of 2. So the rule says f goes on the outside, g goes on the inside. That's 2 this time instead of x. Still going to start on the inside. All right, so start on the inside here. And just go off to the side. Figure out what g of 2 is. And then we'll replace g of 2 with whatever we figure out that is. All right, so plug in 2 into g. That's 2 plus 5, which is 7. All right, so g of 2 gets replaced with 7. So we have f of 7. And this is easy from here. You're just plugging 7 into your function, f. So plug it in 7 into f of x up here. So it's going to be 7 cubed plus 1. 7 cubed is 343. And then plus 1. So that's 344. So it's always easier when you're plugging in the number, especially for these composition of functions. All right, the last one I wanted to show you, and I figured you could add it into your notes if you wanted to, was this one from the homework. It says find f composed with g of 1 for the following functions. And then it just has it written a little bit differently. But we're going to be using the same rules. This one's actually probably even easier than our last one. It just looks different. So find f composed with g of 1 for the following functions, and it tells us that f of negative 2 equals negative 1, and g of 1 is equal to negative 2. This will be the easiest one we've done all day. F composed of g of 1. Go ahead and write out your definition of your rule. Remember, f goes on the outside, g goes on the inside. So it's going to be g of 1 in there this time. Start on the inside. All right, so g of 1. They told us that g of 1 equals negative 2. All right, so just replace g of 1. They told us that was equal to negative 2. And what do they tell you f of negative 2 is? Yeah, negative 1. That's it. So super easy. It just looks different and it looks a little bit complicated. But as long as you apply your rule, it should be pretty straightforward. I'm going to stop the recording, then we'll wrap up.